taking an introductory survey of the muscle size and strength.
Okay, so introduction. The relationship between the muscle size and strength and muscle consists of connective muscle and muscle fiber. We have slow and fast muscle fiber switches in our arms which workout increases the size and quantity of several fibers and increases the size of restricted muscle.
This is our hypothesis, and mainly it was to see that if the size of the arm is related to the ability to lift more weight. So basically, if your arm is bigger, you'll be able to lift more weight, and if your arm is smaller, you'll be able to lift less weight as a person.
Our statistical analysis. Descriptive statistics measure the central tendency, variation, and relative position. These include a mean, median, mode, and standard deviation and quartile of our data sets. Graphical representation of like box plot and histogram.
The materials that we used was first, we had to find the workout room. We then randomly found our participants was the UDMS students, ages 15 through 17. And then we needed a tape measure to measure the circumference of the arm size from this, start from this side, and we measured all the way around back to the middle of it. We then chose the sizes of the weights that we were going to use, which was 10, 20, and 30 pounds. And then we needed a recording table to collect all the data.
Okay, our data collection. We use random sampling techniques, which is basically you have random students or random samples or whatever you want to use, and we present this in raw data type form, which is basically just everything gathered from this. We then treated the data as both categorical, and numerical data for the purpose of explaining our results.
This picture right here, you can see as I was taking Jordan's arm measurement as before all the things, and on W's you can see as she's lifting the bar, that's as many times, we had to lift that as many times until your arm got tired, so we was testing your fatigue. And basically, our data was kind of split up a little bit because we had some athletic people and non-athletic people, which kind of skewed the data.
Okay, for important muscles of the arm. So basically the two important muscles, the bicep and the tricep. The bicep is split into two. It is split into two heads, the long head and the short head, while the tricep is split into three, the long head, the medium, and the light.
The small arms compared to the larger arms, well, basically what we meant by this was that, as I said before, the small arms are the more athletic size arms because you have muscle, so it's not as much body fat around it. It's more muscularized, and the bigger and larger arms are the bigger ones with all the fat around it, shall I say. And also, particular to the smaller arms, was the sizes 10 inches to 12 and a half inches, and our larger arms were 13 inches to 15 inches.
Okay.
The methods that we use in our clinic was we randomly selected the participants, the UDMS students, of course. The weight system, we set that up. We measured the circumference. We then let them lift the weight, the first weight, which was 10 pounds, and they had to lift that to see how many times they could lift it until they were tired. They then did that step for the 20 pounds and 30 pounds. And after everybody went, we collected all the data.
Okay, this is our box plot. So as you can see, it's left view, which means and that's basically saying that you would think that even though people have bigger muscles, they will be able to lift more, but our data was different.
The results that we came up with was more than half of our participants with smaller biceps could lift more than people with larger biceps, or larger arms, shall I say. And that another one was that the more weight that we added on to the bar that they lifted, the harder that it got for them.
our conclusion. At the end of the experiment, we concluded that our hypothesis was wrong, and that people with smaller arms can lift more weight, and that people with bigger arms cannot.
And we would like to thank Ms. Morgan for one. We would also like to thank our mentor, Mr. Emmanuel, in the back, for helping us out this whole summer. We would like to thank Ms. Rogers. Yeah. She was one for me too. And we would also like to thank Ms. Fernandez, our anatomy teacher.
In your report, you listed some terms I'm unfamiliar with. You say categorical and numerical data. What are the differences between the two?
Basically, categorical is basically, you have categories which shows your data, while numerical is basically numbers, another thing.
I'm sorry, will you repeat?
Categorical is while your data is being separated into categories, while numerical data is basically your raw numbers.
It's basically
Raw numbers.
raw numbers. Okay. Thank you.
How long were the students given after lifting more weight?
I would say about 5 minutes because we had to run through all our participants on the first week, and then we did the next round right after that. So that kind of seems like that. Yeah, it did honestly because they some of them didn't recover from the last time that they lifted the weights because surprisingly on the 10 pounds, some arms were very tired, so they couldn't lift the other 20 pounds. So it made it a lot. Any more questions?
The students use the bar for like 10 pounds, 20 pounds, 30 pounds,
Can you go back to the box and plot diagram, please? Can you explain that to me? You glossed over it and I have no clue what this even means.
Okay, so this is the box of this slide. You see it's left speaker, which means it's to the left, and this is basically all of our data stuff put together. And like it's split into categories for medium mode and upper quartile, which is lower quartile test.
I heard medium mode. What is the each of the lines represent? What does the box represent?
It's just the left, which means that even though you would think the people with bigger arms would live more, it didn't prove, our hypothesis didn't prove that, or prove it.
Okay, my question was, what do the lines represent and what does the box represent? What are each of those different parts?
The mean, the mean is the middle one, while the max and minimum are the two outlines, and the upper quartile and the lower quartile is the smaller box and the lower box. The left box is the lower quartile of the right arm.
What was that one that's in the very middle of the box?
The medium.
The numbers on that box, what is that reps, the repetitions, or what is 500 and 1,000?
Well, with the numbers, basically, we got our data set, all the numbers from our data, like all the weights that they can lift. So yes, it is how many reps they can do, but basically we just sum them all together.
So like 10 reps at 10 pounds would be 100, or?
Yeah, the way that we did it, all the numbers that we got, 'cause we got a whole list of different numbers. Since we didn't want to put all them numbers out like that, we just summed them together.
So you added.
Yes.
number of participants use? 8.
This is a comment. I think y'all did really good.